Humankind's insatiable curiosity ignited the advancement of our civilization, allowing for the development of technologies that continue to augment our knowledge and understanding of the universe. The cosmos, once a realm of awe and speculation, pivots now towards an achievable destination, the next frontier of exploration and conquest. One might summarize humanity's excursion into the stars as an endeavor aimed at resolving one of the most perplexing questions. Are we alone in the universe? On October 19th, 2017, astronomers at the University of Hawaii conducted research at the Panoramic Survey Telescope and Rapid Response System, or PAN-STARRS, when they noticed an object traversing our solar system at high speeds. First observed at a distance of 33 million kilometers away from the Earth, astronomers calculated its trajectory, tracing the origin from the direction of the star Vega within the Lyra constellation. Initially referring to the new discovery as Rama, after a spacecraft in one of Arthur C. Clarke's science fiction stories, astronomers opted to honor the local culture instead, landing on the name Oumuamua, the Hawaiian word for a messenger from the distant past, reaching out to us, an object from another solar system, the first of its kind. Astronomers worldwide calibrated their scopes, noting Oumuamua's dark red color, hinting its composition, while an analysis of its brightness helped determine shape and size, though conflicting reports soon emerged as observations around the planet reported different readings. Oumuamua's brightness was not constant, growing brighter then dimmer over the course of a week, leading to the idea that its physical appearance resembled a cigar, half a mile long and narrow, with an access ratio of 10:1. No object ever discovered in our solar system remotely resembles anything close to the dimensions of Oumuamua, baffling researchers who could only speculate as to how this object formed. Further observations revealed that Oumuamua rotates on a short axis, wobbling like a top, spinning on its side while concurrently nodding up and down, a clear indication that it was violently thrust from its home solar system, barreling through interstellar space for an undisclosed amount of time. This revelation prompted astronomers to reimagine Oumuamua's structure, with some theorizing its appearance like an oval pancake rather than a cigar. After the first week, Oumuamua's brightness diminished by a factor of 10. Then, following analyses from several observatories, NASA uncovered that Oumuamua gained an unexpected boost in speed and shift in trajectory as it reached its perihelion on September 9th, 2017, passing within the orbit of Mercury a month preceding its discovery. Researchers at the European Space Agency reported that their high-precision measurements of Oumuamua revealed that something unrelated to the gravitational forces of the Sun and planets had affected its motion, and that the speed boost seemed consistent with the behavior of known comets, expelling jets of gaseous material from the surface, causing an acceleration and creating the signature coma and tail. However, no visible signs of outgassing were identified from Oumuamua. The broadly accepted explanation conjectures that what few dust particles remained from traversing interstellar space allowed a sufficient kick when Oumuamua approached the Sun, though too scarce to be detected or confirmed, captivating astronomers worldwide. One theory suggests that Oumuamua could be debris from a disintegrated exocomet, a comet from interstellar space, tumbling across our solar neighborhood, and its endless time spent beyond our solar system eroded any dust particles, explaining the lack of a visible tail or coma. One other theory, though shunned by members of the scientific community, offers an alternative explanation for Oumuamua's behavior and possible origin. Professor Avi Loeb of Harvard University, an esteemed astronomer with 3 decades of Ivy League experience and a trove of astronomical publications to boot, pointed out several distinguishing features that differentiate Oumuamua from any other celestial object thus far observed. While the majority of scientists settled on the idea that Oumuamua is purely natural, Loeb points out that it moves too fast to be a simple comet, unaffected by the sun, almost as if it's not even there. And though its acceleration did change within the sun's proximity, Oumuamua's rotation rate remained consistent, atypical of outgassing comets. Unavoidably, Loeb's proposition was mostly dismissed within the scientific community, many of whom were quick to ridicule his theory. Accused of lack of motivation, quick assumptions, and sensationalism by prominent astrophysicists, Loeb stands firm on his postulation in the international press, suggesting that Oumuamua could be of artificial origin, perhaps a piece of debris from a light sail or similar advanced technology which humanity may one day possess. In the present, space entrepreneurs like Russian billionaire Yuri Milner collaborate with Professor Loeb to design the first human-made interstellar spacecraft and light sail fleet, as a part of Breakthrough Starshot, co-founded by the late Stephen Hawking and Mark Zuckerberg. During a period in history characterized by massive exponential technological growth and curious space discoveries, the pursuit of scientific truth demands a gamble, as history reminds us, particularly within the realm of astronomy in an ever-changing landscape. In Loeb's own words, the history of astronomy teaches us not to put blinders on our telescopes. Galileo suggested that to the Church. Though most astronomers believe Oumuamua a natural object, our technological limitations make it so we cannot actually prove that it is not something artificial. But of course, it could just be an inert space rock. Since its discovery, astronomers contemplate Oumuamua's nature, how it may have formed in such a way unlike anything we've ever seen in our solar system, most anticipating additional interstellar visitors, believing we are surrounded by them, blinded within the confines of our technological limitations. After all, we reside within a massive universe, with no short supply of mystery and awe. In 2019, their wishes came true in the most unexpected of ways. On August 30th, 2019, amateur astronomer Gennady Borisov made a fascinating discovery when he detected a comet set on a rather odd path. From his very own Margot Observatory located in Crimea, Borisov spotted comet C 2019 Q4, approximately 3 astronomical units from the Sun. The Minor Planet Center announced his discovery on September 11, 2019, after follow-up observations confirmed the comet, reporting that it follows a hyperbolic trajectory and will approach its perihelion, approximately 2 astronomical units, sometime in December of 2019. Though unlike Oumuamua passing through the orbit of Mercury, Borisov's trajectory seems to completely ignore our Sun. Named after Gennady Borisov, a Crimean amateur astronomer discovered the comet with a telescope he built himself After reporting his findings, astronomers around the world, amateurs and professionals alike, began a comprehensive study of this mysterious visitor, ongoing to the date of this posting. The International Astronomical Union's Minor Planet Center and the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory calculated Borisov's trajectory and concluded that it originated from interstellar space, aging Comet Borisov considerably. Astronomers describe Borisov as active, with its trailing visible tail curiously resembling a standard comet. This contrasts Oumuamua, which bears more of a rocky composition and lacks the evident features of a comet. Oumuamua's discovery occurred on its way out of the solar system, while Borisov's trek has only just begun, allowing scientists a wider window to study the interstellar visitor. Researchers hope that an analysis of its chemical composition and structure will offer a historic examination at what planetary building blocks from a distant star system might look like. On October 16, 2019, NASA released footage of Comet Borisov, captured by the Hubble telescope several days prior. Hubble caught the image of Borisov at a distance of 260 million miles away from planet Earth, on its hyperbolic trajectory, racing through our planetary neighborhood at 110,000 miles an hour, unaffected by the gravitational forces that bind our solar system. Sometime in 2020, it will pass Jupiter and resume its infinite voyage back into interstellar space, perhaps visiting other solar systems just like ours. The first two confirmed interstellar visitors serve as a significant marker at the dawn of the golden age of space exploration. It is believed that our solar system might host an abundance of interstellar objects, though most too faint to be seen with our primitive technology. All scopes remain set on Borisov as it continues traveling within our solar system, with the Hubble Space Telescope's superior sensitivity and resolution playing the paparazzi along the way. The origin of both interstellar visitors remains shrouded